Hello, good morning, children. Welcome to Right Tuition Classes. We are doing ICSE Standard 10 Physics, Chapter 2, Work, Energy, and Power, the numericals. Okay, the numericals, what are there as exercise? What are there in exercise 2A? A body, when acted upon by a force of 10 kgf, gets displaced by 0.5 meter. A body, when acted upon by a force, the force that gets exerted is 10 kgf. It gets displaced by 0.5 meter. Got it? Displacement is 5 meter. Calculate the work done by the force when the displacement is first one in the direction of force. Second one, at an angle of 60 degrees with the force, normal to the force. So this first step of doing the problem, whenever you do a problem, is please write down what is given in short. A body when acted upon by force of, this is force, how much it is? They're giving it as 10 kgf, okay? Now 10 kgf, what I do, I convert it into SI unit. SI unit of force is Newton. So this 1 kgf, when I multiply by the G value of G, 10 Newton per kilogram, it will become 10 into 10. When I multiply by 10, it will become 100 Newton. So remember, 1 kgf is 10 Newton. 2 kgf is 2 Newton. 3 kgf is 1 kgf is 10 Newton. Okay, so 2 kgf will be 2 into 10, 20 Newton. 3 kgf will be 3 into 10, 30 Newton. So my 10 kg will be 10 into 10, 100 Newton. Okay. And displacement, S kitna hai beta? 0.5 meter. Got it? Now, all are in SI unit, no problem. Now, calculate. I want to calculate the work done when force is, when the displacement is in the direction of force. So, first one, when displacement is in direction of force. Displacement is in direction of force, children. So naturally, children, here, please keep it in mind. You know this displacement is in the direction of force. So whatever, please here, my formula, when displacement is in the direction of force, work done is equal to F into S. F into S. So what is F here? See, what F I put on top, okay? This also, I'll put it as F. Okay, so F into S. So how much it will become? 100 Newton into 0.5 meter. Okay, so this will become F 100 Newton. S के जगह में 0.5 Newton. तो ये हो जाएगा बेटा, देखो डेसिमल, एक जीरो डेसिमल को शिफ्ट कर देगा तो 5 बन जाएगा. 5 into 10, 50 Newton meter. 1 Newton meter is 1 joule. So 50 Newton meter, 50 joules. Got it? So remember, children, work done in the first case, when displacement is in the direction of force, the work done is 50 joules. Now, at an angle of 60 degree, when displacement is at an angle of, angle of 60 degree, got it? 60 degree with the force, okay? With the force. So naturally, children, what you see is, children, here, okay, the displacement is making an angle of 60 degree with the force. Then in that case, when the displacement was in the direction of force, I gave you the formula W is equal to Fs. And when it is making some angle like this, I given you the formula W is equal to F into S into cos theta. Got it? So what is theta here? Theta equals 60 degrees. Okay. So you can see here, children, what is work here? Force is 100 Newton. Okay. What is S, children? S is 0.5 meter into cos of 60 degree. Cos 60 is half. Cos 60 is half. Cos 60 is half. We know it by heart. 100 Newton into 0.5 meter into half. Okay. So what I get here, children, equal, see, 50 into, this will become 50. 100 into 0.5 is 50. 50 into half is 25. 25 joules. 25 Newton meter is left. That is nothing but 25 joules. I hope people are understanding. I hope this is simple sum, children. Okay, I'm sure everybody only remember when displacement is in the direction of force, W is equal to Fs. When displacement is at an angle of 60 degree with the force, W is equal to Fs cos theta. Now, what is the third one, children? The third one, normal to the force. Displacement is normal to the force. What is the third one, children? Displacement is normal to the force. What is the third one, children? Displacement is normal to the force. So here I'm going to write, children, displacement is normal to the force. Okay. So here the third part, I'm going to adjust it here, squeeze in here. The next third one, when displacement is in the third one, when displacement is normal to the force. Normal matlab perpendicular. Perpendicular matlab they make an angle of 90 degree, theta equal 90. So W is equal to F into S into cos theta beta. So you put a value, children, doesn't matter. This is 100 Newton. This is 0.5 joules. 5 meters, sorry, but cos of 90. Now cos of 90, when you see cos 90 is 0, children. Cos 90 is 0. Cos 90 is 0. Okay. So what will happen, children? Here, 100 into 0.5, 100 Newton into 0.5 meter into 0. Any number multiplied by 0 is 0. So ultimately 0. The work done will be 0. Work done will be 0. I hope people have understood me here. So remember one thing, learn it, children. When the displacement is in the direction of force, formula for W will be, work will be F into S. When the displacement is at any angle with the force, W is equal to Fs cos theta. Now, please have a look here. We are going to do the question number 2. A boy of mass 40 kg. A boy of mass 40 kg climbs up the stairs. The boy is using a force to climb up. Got it? A boy is using a force to climb up. So a boy of mass 40 kg climbs up the stairs and reaches the roof at a height of 8 meters in 4 seconds. Calculate the first part of the question. Force of gravity acting on the boy. Second part of the question. Work done by him against the force of gravity and power spent by the boy. So simple this sum is, children. The first one, what I'm going to do, first thing what you do is write down what is given in short. So the boy of mass, so M is 40 kg, so it's an SI unit, no problem, okay? Climbs up the stairs and reaches a roof at a height of 8 meters. He has reached a height of 8 meters. This is the displacement upward, okay? Now, in 4 seconds, what is the time taken for him? 4 seconds, okay? Now, first part of the question is the force of gravity acting on the boy. Force of gravity. What is force of gravity, children? The gravitational force of attraction exerted by the earth on the body. So that is called force of gravity. What is the other name for force of gravity? Weight of the body. So it's one and the same. So this force of gravity acting on the body is nothing but weight of the body. वेट का फॉर्मूला क्या सीखा बेटा 9 पे mg, तो m तो दिया है, g भी दिया है, तो दोनों को यूज करके आंसर निकाल सकते हैं. So what is that force of gravity? First one, force of gravity. Please have a look at this. Force of gravity acting on the boy, is nothing but, please have a look at, is equal to weight of the boy. That is why I use a formula. Weight kya hai? M into G. Got it? So how much you get? M is how much? You can see here. M is 40 kgs. And what is G, children? G value 10. They're given 10 Newton per 10 meter per second square. So what will happen, children? When you multiply, you get 400. What do you get, better? 400 Newton. What is that? 400 kilogram meter per second square is 1 Newton. Okay. So 400 Newton. Okay, children. Force of gravity acting on the ball. Now, work done by him against the force of gravity. So remember, beta, the force F exerted by the boy, force F exerted by the boy, exerted by the boy, by the boy, by the boy will be equal to his weight, okay? His weight of the boy. What is the weight of the boy, beta? You know, children, on top, you can see here, what is the weight of the boy, beta? Therefore, F is equal to, what is the weight of the boy? We got 400 Newton. Okay, why did I find F? Correct? See, what is the work done? Work done by the boy, work done by the boy against the force of gravity is equal to F into S. Either force is 400 Newton, okay, and S is nothing but the displacement upward. Okay, height is 8 meter. So it is 8 meter. So how much you get? So it will become 3200 Newton meter, but this Newton meter is nothing but joule. So 3200 joules, okay? So the work done by the boy is 3200 joules. Now, next, the power spent by the boy. I want the power. If power is formula, power is the rate at which the work is done. Matlab, work upon time, okay? So how much work the boy has done in 1 second? That is power. So work done by him is 3200 joules. And the time taken is 4 seconds. You can see they are given. So 800. So it will become 800 joules per second. 800 joules per second is 1 joule per second is 1 watt. So 800 joules is 800 watts. Got it? So power is 800 watts. I hope people understand me here. A man spends 6.4 kilojoules. Matlab he does work, energy. A man spends energy, matlab he has done that much work. So man spends 6.4 kilojoules energy. Matlab he has worked 6.4 kilojoules. In displacing a load of 64 meter, displacing a load by 64 meter in the direction in which he applies force in 2.5 seconds. Calculate the force applied. So simple, Peter. See what is given. I'm going to write it in short. See, indirectly, a man spends 6.4 kilojoules. Matlab, he has done a work equal to 6.4 kilojoules. So work equal 6.4 kilojoules. Matlab, 6.4 into K matlab 1000. 6.44 kilojoules is a higher unit. It's not an SI unit. मेरे कैलकुलेशन का टाइम में मेरे को SI यूनिट मांगता है तो क्या करूंगा 6.4 into 1000 पूरा joules हो जाएगा. That is nothing but 6400 joules. Okay. Now a man spends 6.4 kilojoules energy. It does so much work in displacing a load by 64 meter. Oh, S is 64 meter. Correct? Which he applies the force in 2.5 seconds. Time is 2.5 seconds. The first part, force applied. So please have a look here. W is equal to F into S. Work done there. Force there. Displacement. Force which had displacement. So naturally, the mind tells us use this formula. So W is not much. 6,400 joules. If you want to put units, you can put units. If you don't want to put units, don't. You should know all the units. You should know. But what I do is I put 6,400 joules. Force we don't know. Force is what I want. And 64 meter. So naturally 6,400 joules upon 64 meter. A joule per meter is nothing but Newton. So F is equal to 100 Newton. So this is one answer, force applied. Okay, what is the second answer? The power spent, power waste, the rate at which the work is done. मतलब work done in 1 second. So naturally work को total time से divide करो. Work कितना है 1000, work कितना है 6400 joules. अब टाइम कितना लगा आपको टोटल टाइम 2.5 seconds. Now you can do it easily. 6400 into 10, the whole thing upon 25. When I shift the decimal by one place, so I put 10 on top. This is joule per second. So ये कैसा होएगा देखो बेटा कितना सिंपल है. Okay, 25 pies, 25 pies are 25, 5 twos, 5 ones are 5, 5 ones are 5, 5 twos are 10, 40, 5 eights are 40, 0. So this is 2 pi 6, 2 pi 60 watt. 1 joule per second is watt, 1 watt. So power spent is 2 pi 60 watt. Okay. Now we go to the next sum. Question number 3. A man spends 6.4 kilojoules energy in displacing a load of 64 meters in the direction in which he applies force in 2.5 seconds. Calculate the force applied and the power spent in horsepower by this man. Okay. Again, I repeat the whole thing, children. Very simple. Okay. A man spends 6.4 kilojoules of energy in displacing a load of 64 meters in the direction in which he applies force in 2.5 seconds. Calculate the force applied and power spent by the man. So I told you the first step in physics while tackling a physics problem is write down all in notation form, whatever is given, okay? So see a solution. What is given, children? Let's see here. A man spends 6.4 kilojoules. Hey, man spends matlab, that is a work done. Okay, the amount of work he does is nothing but the energy he spends. So man spends matlab work done. Okay, so what is the work done, beta? Work done is 6.4 kilojoules, but kilojoules is just an higher unit of work. So it's not an SI unit. So 6.4 into 1000. Kilo matlab K is kilo. Kilo matlab 1000 joules. Are you getting me? And that kilo gets converted. Okay, 1000 joules. So basically, it is nothing but 6,400 joules. Okay. So now, displacing a man spends 6.4 joules kilojoules energy in displacing a load by 64 meter. Displacement is 64 meter in the direction in which he applies force in 2.5 seconds. This is 2.5 seconds. Okay. Now what they say, calculate the force applied. So see, so simple. Force applied work is equal to force into displacement. So 6400 is equal to force into 64. So what will happen? 6400 upon 64 is equal to F. So F is equal to 100 Newton. So F is equal to 100 Newton. So force applied equal 100 Newton. What is the next part of the question, children? The next part, they want me to find the part in HP by the man, okay? They want the part spent by the man, but in horsepower. So you can clearly see, beta, power is what rate at which the work is done. That is the work done per second. That means to find power, we should know work and we should know the time. So what is the work the person has done? 6,400 joules. And what is the time taken by the man? 2.5 seconds. He has taken exactly 2.5 seconds. So 2.5 seconds. That means so many joules in 2.5 seconds. So naturally, 6,400 into 10 upon 25. 5 5s are 5 2s are 5 1s are 5, 14, 5 2s are 10, 8 0. So ultimately 2560 watts. But this is not the answer I want. I want the power in horsepower. I want the power in horsepower. What is this? I want the power in horsepower. Just 1 minute, children. I'll just make place for me to do it. Okay. So what I'll do is, yeah. So 1 horsepower is 746 watts. याद रखो. 1 horsepower is 746 watts. So 2560 watts will be how many horsepower? Got it? याद रखो. So what will happen? This will go up. So if I want, therefore power is equal to, if I want it in 2560 divided by 746, I'll get in horsepower. Okay. So when I do, how much I get, it will be approximately 3 point, it will come to 3.43 horsepower. Okay, children. So try to understand this. Okay, children. Very simple. Question number 4. A weightlifter lifted a load of 200 kg to a height 2.5 meter in 5 seconds. Calculate the work done and the power used by the weightlifter. Okay, G is equal to 10 Newton per kilogram. So simple, children. First step, what I told you, always whatever is given, we'll write it in notation form. A weightlifter lifted a load of 200 kg. He lifted a load. Got it? So the weight, okay? Weight of the load is how much, children? Or load is equal to, load is nothing but the weight, okay? Load is nothing but a weight. How much it is? 200 kg. 200 kg. If I want to convert into Newton, multiply by 10. 200 into 10. Kitna ho gaya beta? 2000 Newton. Okay. So the load what he uses, what he lifted is 2000 Newton. And to the height, okay, what is H? Height is 2.5 meters. And what is the time, children? Time is, it has taken him 5 seconds to do it. So first part of the question is work done. Work done, please have a look here. Work done, whenever you lift an object, you apply a force equal to the weight. This is the force. And the displacement is S, ka badle H. Whenever you lift an object, the minimum force you apply is equal to the weight. And you lift it towards certain height, that is the displacement is H. So work is force into displacement, that is mg into H. So hamesha yaad rakho mgh. So here, this load was nothing but, try to understand, this load is your mg. This load is nothing but, children, it is mg. Got it? The load equal, therefore I'll just put it like this, m into g equal 2000 Newton. So naturally 2000 into displacement is 2.5. So what will happen, children, that 1 0 gets used up, okay? So it will become 5,000, what I can say, joules. Got it? 1 0 gets used up. So 25 into 200 is 5,000, okay? Now, what they want the power. Power is very simple, children. What is the formula for power? Power is work upon time. I want power, children. Power is the rate at which the work is done, or work done per second. If you want the work done per second, you'll have to divide that work by the total time taken. Got it? So the work what you did was 5,000 joules. And what is the total time taken by you was 5 seconds. So this becomes 1,000 joules per second. Okay? And this joule per second is nothing but watt. So yaad rakho, either W, capital W, okay, or everything in small letters. Either capital W or everything in small letters. 1000 watt. Are you getting me? Okay. So the answer, we got it. Okay. 1000 this. Okay. We go to the next sum, children. A machine raises a load of 750 Newton through a height of 16 meter in 5 seconds. Okay. So machine raises a load of 250 Newton. Newton is a unit of force. The load is nothing but weight, children. So what happens is, solution, if you ask me, whenever I see a load, especially work wala example me, got a load, I'll take it as mg, m into g, how much it is, children. 750 Newton. Only thing, we don't do any calculation, but a load is the weight he's lifted, okay, through a height, h. H is how much, children? Height is 16 meter. And what is the time taken by him? For 5 seconds again. Now, first part of the question is energy spent by the machine. The energy spent by the machine is the work done by the machine. Energy spent by machine is equal to work done by the machine. Work done by machine. So what is the formula for work done, beta? The work done is nothing but mg, force into displacement, mg into h. Force into displacement. What is the mg, children? Mg is, you can clearly see, 750 Newton into h is how much? 16 meter. So how much you get? 16 zeros are 0, 16 fives are 80, and 16 sevens are 112, 120. Okay, so 12,000 Newton meter. This is nothing but 12,000 joules. Got it? So remember, children, the energy spent by the machine is 12,000 joules. Now, the power of the machine, if it is 100, see, efficiency of the machine is 100% is given. Matlab, no energy is lost anywhere. Whatever is the input energy, the output energy is going to be the same. That means the output of the machine, therefore, output of the machine is 12,000 joules, correct? Input energy spent by the machine is 12,000 joules. Now, what is the question here? Power of the machine. Power is the work output of the machine upon time. The work output is the same beta because 100% efficient 12,000 hi rahega. Upon time, time is how many? 5 seconds. So how much you get? 24, 122,400 capital or small WATTS. What? Are you getting me? Or capital W. Okay, children. Now I come to the an electric heater of power 3 kilowatt. Electric heater of power 3 kilowatt. So what is power, children? Power is 3 kilowatt. Okay, matlab 3,000 watts. But 3,000 joules per second. Are you getting me? It is doing a work. Okay, it is used for 10 hours. Time is 10 hours. Time is 10 hours. Okay, it is doing 3,000 joules of energy per second and it has been used for 10 hours. How much energy does it consume? So basically, energy, see, power is work upon time. That is energy upon time. So energy consumed equal power into time. So naturally, they want it in kilowatt hour. This can be taken as kilowatt. Okay. So what I'll do is 3 kilowatt into 10 hours. So it becomes 30 kilowatt hour. This is first answer. But then they also want it in joules. 1 kilowatt hour, 1 kilowatt hour, please have a look here. 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joules. Therefore, energy consumed is equal to 30 kilowatt hour is equal to 30 into 3.6 into 10 raised to 6. 30 into 3.6 into 10 raised to 6. This will become 30 will go, decimal goes 108 into 10 raised to 6. But in physics, always remember, children, you should write the answer. The decimal should come to the left of the decimal 1 digit. Suppose if I put decimal here, to the left of it, I will get 3 digits. I don't want like this. I want to the left of the decimal only 1 digit. So naturally, children, how you go about? Okay, so listen here, children. This is 108 multiplied by 10 raised to 6. So if I put the decimal here, 1.08. So 108 ka 1.08 matlab 100 into 10 raised to 6. So this becomes 1.08 into 10 raised to 8. Got it? What I can say is energy consumed. Joules, so many joules. Are you getting me here? Okay, children? Is it clear to everybody? I'm sure. Everybody must have understood it, okay? Now, we go to the see, a water pump raises 50 liters of water through a height of 25 meters in 5 seconds. Calculate the power of the pump required. Okay, G is 10 Newton per kilogram density of water. So remember, children, I want to calculate the power. Power is work upon time. Work will be work in terms of lifting examples. Anywhere when you lift, work will be mgh upon time. So m is mass of water. So the mass of water is not given, children. What is given? Volume of water is given, 50 liters. Got it? 1 liter is 50 liters. If I want to convert into meter cube, divide by 1000. So it becomes 5 upon 100 meter cube. Density of water is given 1000 kilogram per meter cube. So I think density is mass upon volume. So mass of water should be volume of water into density of water. 5 upon 100 into 1000. How much I get? 50 kilograms. So I got mass. Power is work upon time. M into G into H upon time. So M is 50. G is 10. Height is 25 meters upon 5. 5 1 time, 5 10 times. So 2500 joules per second, 2500 watt. I hope people understood this sum. I repeat, see, a water pump raises 50 liters of water, a volume bola, through a height of 25 meters in 5 seconds. Calculate the power of the pump required. G is given 10 Newton per kilogram. Density of water is 1000 kilogram per meter cube. So listen, volume of water is 50 liters. 50 upon 1000. If I divide, it gets converted into meter cube. So 5 upon 100 meter cube, volume of water. Density of water is given. But you know, power is work upon time. Work upon like mgh upon time. I want the mass of water. So see how we get it. Density equal mass upon volume. So mass of water equal density into volume. Volume into density. Volume is 5 upon 100. Density is 1000. So when I cancel it, 50 kgs. So mass of water is 50 kgs. Got it? The power is work upon time, mgh upon time. M is 50, G is 10, GH is 25 meters, upon time is 5 seconds. So 2500 joules per second, that is 2500 watts. or you can say 2.5 kilowatt. Okay, children, simple sum. Okay. Question number 8. A pump is used to lift 500 kg of water from a depth of 80 meter. Matlab, 500 kg mass of water to be lifted is how much, children? I told you, every time we will write first in notation form, okay? Everything in notation form. So, please here, a pump is used to lift 500 kg of water. 500 kg of water, that means M is how much? 500 kg, okay? Water from a depth matlab height, it has been lifted. This 500 kg of water is lifted to a height h, that is, which is 80 meters. And the time taken is 10 seconds for doing it. So the first part of the question is calculate the work done. I have told you children, work ka formula hai, correct? Please keep in your mind, force under displacement. But in case of lifting example, the minimum force you have to apply is equal to weight. Okay, to lift a thing, the force you have to apply is always equal to weight. So force is mg and displacement is h. So work done in case of lifting example is always F into S ka jagah mein mgh. So what is this? Mass of the water to be lifted. How much is the mass of the water to be lifted? 500. What is the value of G given in the question? 10. And what is the value of H? It has to be lifted to a height 80 meters. So all in SI unit, no problem at all. So 1, 2, 3, 4, 5. 4 and 5 zeros it will come. 1, 2, 3, 4. 4 zeros of the civil here. 8 5s are 40. So 1 more zero. So it becomes 4 lakh. Please have a look at joules. You can always write it as 4 into 10 to the power 1, 2, 3, 5 joules. Okay, no problem. Now, please here 4 into 10 to the power 5 joules. Okay, then comes your power at which the pump works. Power at which the pump works. This is the A part. Okay, now B part. Power is always work upon time. Power is work upon time. Power is work done in 1 second. मतलब 1 second में कितना work किया? That work, how do you get? Work upon time करके. So power is work upon time. Power is 4, 1, 2, 3, 4, 5. So many joules upon time is, please say it has taken 10 seconds. So 1010 cancel. So how much it becomes? 40,000 watt, 40,000 joule per second, which is nothing but 40,000 watts, okay, capital W, and equal 40 kilowatt, okay. You can also write it as 40 kilowatt, okay. The power at which the pump works, 40 kilowatt. Now they're saying, children, that this part is very interesting. The power rating. What is this power rating? Always remember, power rating is the power, the input work is called a power rating. Power rating of a pump, if its efficiency is 40%. Got it? So I think, please input power, okay? So see here, children, efficiency is 40% they're giving. So efficiency is output power upon input power, because they want power rating. So input power is power into 100. Okay, I'll tell you why I'm making it 100. So it is 40, percentage, in terms of percentage. So 40 equal output power is 40,000 watts. 40,000 upon input power. So when you calculate, children, when you try to calculate, I'll make place for it. Okay, when you calculate, input power, how much you get, children? Therefore, input power equal input power. Oh, so sorry, children. input power equal 40,000 upon 40,000 upon 40. So when you do this, it works out to 1,000. So what is this? 1,000 input power is 1,000 1 minute, somewhere I did a mistake, children. This is 4 lakhs, okay? 40,000. Oh, into 100 is that, children, into 100. Are they into 100 is that? Okay, into 100. Into 100. So how much I get? 1, 2, 3, 4, 5. So I can write it as 100 kilowatt. 100 kilowatt. What I can write? 100 kilowatt. So this input power is nothing but power rating. So power rating of the pump, power rating is equal to input power. How much is input power? Input power is nothing but 100 kilowatt. 100 kilowatt. Okay, it is 100 kilowatt. Okay, children, we go to the next sum. Okay, now an ox can apply a maximum force of 1,000 Newton. It is taking part in a cart race and is able to pull the cart at a constant speed of 30 meters per second while making its best effort. Okay, calculate the power delivered by the axe. So this ox, how much force it is applying? 1,000 Newton. At what speed it is able to pull the cart? 30 meters per second. So what is the power applied? So I told you power is also equal to force into velocity, one formula, okay? Power is force into velocity. That is 1,000 Newton into 30 meters per second. And you get the answer 30,000 watt. 30,000 watt is nothing but 30 kilowatt, okay? One more thing, children, just to help you understand, remember this formula. Power is work upon time. Power is force into work is displacement. Please here. Power is work upon time. So power is force into displacement. Work is force into displacement upon time. Work is force into displacement upon time. वो displacement को time के साथ लिखता है. So displacement upon time is velocity हमेशा. So power is force into velocity. Okay, children. I'm sure everybody will be able to remember this formula. Okay, children. We go to the next sum. Question number 10, children. The power of a motor is 40 kilowatt. At what speed, matlab power is given, at what speed can a motor raise a load of 20,000 Newton? So if you ask me the solution, what I'm going to do first, I'm going to write everything in notation form. The power of that power is 40 kilowatt, okay? This is not SI unit, higher unit. So SI unit may 40,000 watt, okay? Always. Now, at what speed? Oh, speed they want. Can it raise a load? Load is nothing but force, okay? Of 20,000. So what is the force beta? 20,000 Newton, okay? And what they want the speed. So now only we saw power is force into velocity, children. So 40,000, I told you an SI unit, kilowatt is a higher unit. You make it into SI unit, 40,000 watt equal 20,000 into V. So 40,000 upon 20,000 is equal to V, children. That is 2 meters per second. So V is equal to 2. 20 also gets cancelled. 2 meters per second. Okay. So it will carry a load, raise a load at the speed of 2 meters per second. So I hope people understood me. Okay, it will carry at what speed? So it can carry. Okay. Question 11. Rajan exerts a force of 150 Newton in pulling a cart at a constant speed of 10 meters per second. Calculate the power exerted. Very easy, beta. Force is 150 Newton. Velocity is at what speed, beta? 10 meters per second. Velocity is 10 meters per second. What is power exerted by Rajan? Power will be force into velocity. The force and velocity is given 150 into 10, 1500 watt. That is 1.5 kilowatt. Okay, children. Now, question number 12. A boy weighing 350 Newton climbs up to 30 steps, each 20 centimeter high. मतलब एक step 20 centimeter high है. 30 steps चढ़ता है. That means he has climbed the total height of 30 into 20, 600 centimeter, which is 6 meter in 1 minute. How much time it takes to climb this 600 centimeter, 6 meter? 1 minute. Calculate the work done and power spent. So weight of the boy is mg, 350 Newton. Number of steps 30, height of each step 20 centimeters. The total height climbed is 30 into 20, 606 meter. And what is the total time taken? Okay, is 1 minute to do this job. That is 60 seconds. So now work done is, see, the minimum force he has to apply is equal to its weight. See, force into displacement. Minimum force he has to apply is his weight, mg, into the height. Displacement is height. Mg, weight how much? 350 Newton into 6. How much? 2100 joules. So total work done is 2100 joules. Now what is the power spent? Work upon time. 2100 joules, he does it in 1 minute, 60 seconds. So in 1 second, kitna? 35 joules. So that is 35 watt. So power spent by the boy is 35 watt. Okay, children? Now we go to the next question, children. Question number 13, children. It takes 20 seconds for person A of mass 50 kg to climb up the stairs, while another person B of the same mass does the same in 15 seconds. Compare the work done. See, I'll just say like this, children, while doing, just to help you understand better. I make two groups, person A, two columns rather, person B. Let me write the condition in short now. It takes 20 seconds for person A to make of mass 50 kg. What is the mass of this person A? 50 kg. Matlab MA 50 kg. And what is mass of person B? Same mass he has, okay, 50 kg. To climb up the stairs, okay, it takes 20 seconds for person A of mass 50 kg to climb up the stairs. Okay, how much time is taken by this person? The time he takes just how much? 20 seconds. While this person takes, person B, he takes just 15 seconds. Now, question is, okay, compare the work done. Compare, compare matlab ratio. Hamesha ratio. Compare matlab ratio. They want the ratio of the work done. Okay, that means they want work done by A upon work done by B. Work done by A will be mass of A into G into H upon mass of B into G into H. Both are 50. G ka value, H ka value same hai. They are climbing to the same height. They're climbing to the same height. So everything gets cancelled. Kya aayega beta? 1 upon 1. So compare the work done. The ratio of the work done by A and B is 1:1. Sure. Next, they want you to compare the power developed. See, power developed by A upon power developed by B. This is WA upon TA divided by WB upon TB. So when you do it, WA, I'll put it here, WA upon TA multiplied by W reciprocal TB upon WB. So this will become WA upon WB. I take this ratio into TB upon TA. Now, what is this 1 upon 1? WA upon WB is 1 upon 1. What is TB, children? 15. What is this? 20. So 5 3s are 5 4s are. So what is the ratio? PA upon PB is 3 upon 4. So ratio of the power developed, ratio of power developed is क्या आएगा बेटा इधर 3:4 is 3:4. Got it? Ratio of the power developed is 3:4. Now we go to question number 14. A boy of weight 40 kgf climbs up the 15 steps, each 15 centimeter height, in 10 seconds. And a girl of the weight 20 kgf does the same job, okay, climbing the stairs, 15 steps in 5 seconds. Compare the work done and power developed by them. So I'll just say for boy, please have a look here. For boy, I'll write it. What is the weight of the boy? Weight of the boy is usually mg. Mg is how much they're giving children? Weight is 40 kgf. 40 kgf. If I multiply by 10, g ka value 10, I'll get 400 Newton. So what is the weight of the boy? Mg is 400 Newton. And he climbs 50. Number of steps kitna? 15. Number of steps equal 15. And height of each step kitna? Height of each steps. Height of each step is 15 centimeter. So total height he climbed. Total height he climbed is 15 into 15. One step, 15 steps. 15 steps, 15 into 15. That is 225 centimeter. That is 2.25 meter. And okay, for a girl, okay, what they're given. Of weight 20 kg. What is the weight of the girl? Better weight of the girl will be equal to her weight also is given by mg. Mass of the girl in that, but that has come directly as 20 kg. That is 20 into 10, 200 Newton. She also climbs the same number of steps, 15. Height of each step कितना है? 15 centimeter. So total height कितना हो गया? Total height is equal to h 15 into 15 कितना हो गया? 225 centimeter. That is 2.25 meter. Now, what is the first part of the question? Compare the work done. So, work done by boy upon work done by girl. Compare मतलब ratio. Compare. Okay, तो क्या आएगा बेटा इधर? इधर आएगा mgh upon mgh. Even please have a look here. For the boy and for the girl, mg for the boy is 400. This is for the boy. And this mg for the girl. Mg for the boy is 400. Height is 2.25. mg for the girl is just 200. Height is 2.25, same. So 200, 2 are, so 2 upon 1. So what is the ratio, children? 2:1. Now they wanted to find the total power developed by them. The power developed by boy, power developed by boy upon power developed by girl is equal to work upon time. Work of boy upon time divided by work of girl upon time taken by the girl. So what do you see? Okay, the boy takes 10 seconds, whereas the girl takes 5 seconds. So what will happen, children? Therefore, can I rub this side, children? I'm so sorry, there is no place left, okay? I want the power developed ratio of the, compare the power developed by them. So the power developed by, please have a look, I'm rubbing the question here. Okay, the power of the boy upon power developed by boy, power developed by boy upon power developed by girl. So what will happen, children? Power is work upon time. The work done by the boy was, how much was the work done by the boy, children? You have got it. The work done by the boy. So I'll put it like this. Work done by the boy upon time taken by the boy divided by. So multiply by time taken by girl upon work done by boy. Okay, the work done by girl. So, okay, what will happen is, children, it will become work of boy upon work of girl. I'll take the work together and I'll take the time taken by them together. Time taken by the girl to the time taken by boy. So how much will you get it here, children? You can see it here for clearly, children. Work done by the boy, the ratio is 2 upon 1 into time taken. Please have a look here. Time taken by the girl. How much it is? Time taken by the girl was just, it was, the girl had taken, if you see, 5 seconds, whereas the boy had taken 10 seconds. 5 ones are 5 twos are, 2 gets cancelled. So 1 upon 1. So ratio of the power developed is 1:1. So ratio of the power developed is 1:1. Ratio of the power developed is 1:1. I hope people understood this sum. We go to the next sum. Question number 15, children. A man raises a box of mass 50 kg to a height 2 meters in 20 seconds. मतलब एक आदमी है बेटा, he raises a box of mass 50 kg to a height of 2 meters in 20 seconds. Another man, second man, he raises the same box to a same height. Oh, 50 seconds में time ज़्यादा लग गया. Compare the work done and the power developed. Also calculate the work done, the power developed by each man. So 2 questions are there. Anyhow, for first man, I'll say for first man. Okay, see how I go about. I'll just put it in systematic way. For first man, what is the mass? 50 kg. Okay, raises to a height 2 meters. And time is 20 seconds. While another man, for second man, I'll say another man is second man. The mass is same, 50 kg. He also raises it to the same height, 2 meters. But the time taken is 50 seconds, T2. Now compare the work done. So work done, A part. Compare the work done. Work done by man 1 upon work done by man 2. Should be M into G into H upon M into G into H, right? Because everything is same. Mass is same, G is going to be same, H also is same. So how much you get? 1:1. So work done by man 1 upon work done by man 2 equal 1:1. The second part they want, sorry, this may A may first part. Now second part of A is they wanted to find the power developed by man A. So power developed, power of man 1 upon power of man 2. His work done by man 1, work done by the man 1 upon T1 divided by work done by the man upon T2. So when I look at it, children, this is work done upon work done upon work done. Work done is going to be same, children, by both of them, into reciprocal T2 upon T1. So here, so 1 upon 1 है बेटा. So 1 upon 1, the ratio of the work done is 1 upon 1. T2 is how much, children? 50 seconds. And earlier man has done it in 20 seconds. Got it? So how much it is? 5:2. Ratio of the, so compare the power developed is 5:2. Okay, work done is much. Now B part, children, they want you to compare the, calculate work done by each man. Each man is equal to, got it? How much it will be? M into G into H. M into G is how much? 50 into 2 is 100 joules. Work done by each man. Okay, he does the same work. Both of them do the same work. Got it? But what is the power of man first? Power of first man. Power of the first man. Work upon time. 100 upon T1. T1 is how much, children? He has taken 20 seconds. So how much it will be? 5 watt. Power of the second man. Is W upon T2. How much is W, children? 100 joules. And he has taken 50 seconds. So this is just 2 watts. So power of the first man is 25 watts. Power of the second man is 2 watts. I hope people understood this. Okay. Then we go to the next sum. Question number 16. A boy takes 3 minutes to lift a 20-liter water bucket from a 20-meter deep well. While his father does it in 2 minutes. A, compare 1, the work, 2, the power, developed by them. And how much work each does. How much work each does. Density of water is 1010⁻³ kilogram per meter cube, and G is 9.8 Newton per kilogram. Okay, children, I didn't know, unnecessary, same type question. Only thing, a boy takes 3 minutes to lift a 20-liter water bucket from a 20-meter deep well, while his father does it in 2 minutes. Got it? That means for the boy, please here, for boy. I'm going to do for boy. Takes 3 minutes to lift a, 20-liter. So volume of water equal 20 liters. Okay. While and this is V, and D density is 1000 kilogram per meter cube. Time taken by the boy is just 2 minutes, 3 minutes. Of course, you can do it in seconds. Time taken by the father is 2 minutes. Now, they want me to compare the work done by the man, work done by the boy upon work done by the father. Since mgh with a mgh, okay? So what is the mass of the water? Please here, mgh. Okay, both are climbing it to the same height, okay? So the mass of water is going to be the same, 20 liters है, जो भी mass आएगा, mass will be 20 kg. So दोनों के लिए mass, boy and father, the mass is going to be same. Even acceleration due to gravity is same, and they're lifting it to the same height. So naturally, it will be 1:1. Got it? Then power developed. Power developed will be power of the boy upon power of the father. This will be work, whatever work boy does, work of the boy upon, please have a look at how much time it takes for him. It takes for him 3 minutes, 3 into 60. And for this man, it just takes 2 into 60. So work will get cancelled. So ultimately, it will be 2 into 60 upon 3 into 60. So it will become 2:3. I hope I've done it in short, children. Now, the B part of the question. How much work each does? Got it? So here, volume equal, density equal mass upon volume. So mass equal, mass of water equal density into volume. So this is, density is how much, children? Just have a look here. Acha. One more thing. Volume equal 20 liters. That is 20 upon 1000 meter cube. Okay. So what will happen? Density, the mass of the water equal, density is 1000 into 20 upon 1000. So ultimately it becomes 20 kg. What is mass of the water? Got it? So now you can see, children, work done by the boy upon work done by the boy equal work done by the man, father, work done by the boy equal work done by the boy equal work done by the father equal mgh. M is how much, children? 20. G is how much? 10. Oh, 9.8. They're giving it as 9.8. 9.8. And what is this H is given as? Height is 20 meter deep. So this will be 400 into 9.8. That is 40 into 98. That is 0. 4 8s are 32. 4 9s are 36. 36. 4 9s are 36. 39. 3920 watt. So work done by each of them is 3920 watt. Now they want how much work done, okay? Okay, we got it. Okay, that is 3.92 kilowatt. Okay, children, with this, we'll stop it.